So we aren't limited to just studying vectors in two-dimensional space. We also need to recognize that we can have 3D vectors as well. And so in order to be able to, at least to some level, understand three-dimensional vectors, we have to be able to visualize three-dimensional space. And so typically, there's one of two ways that 3D space is attempted to be represented through kind of a coordinate system. We're not going to be doing a lot of sketching in 3D drawing, but we still need to be able to kind of visualize things in 3D space. So in the first coordinate plane that we see here, it's a little bit confusing, but we've got x. The positive x-axis is actually coming out of the paper, out of the screen at us. And so then if we imagine kind of our standard xy coordinate plane the way we would draw it just on paper, you think about it as if the positive x-axis is coming at us, then that means that the positive y-axis is going to be going to the right. And then we have the z-axis, which is running in the plane of the paper or the screen that's in front of us. And so even though this is a little bit confusing, the reason this is done is so that the 3D space that is kind of popping out of the screen or popping out of the page is where the x, y, and z coordinates are all positive. So I'm not going to mark up the diagram, it's only going to make things worse, not better. But if you can kind of picture with the x-axis coming out of the page, the y-axis and z-axis running in the plane of the page or of the screen, then that means the region where the x, y, and z coordinates are all positive is going to be kind of out above the screen kind of in front of us. The second option of how we can represent 3D space is used less in textbooks, but might be a little bit easier for us to kind of picture things. So now we have the x-axis that's running in the same direction as we see here. So it is in the plane of the page. Then we have the y-axis, so imagine if it's just tilted into the page. So the y-axis is extending kind of into the depth of the page or into the depth of the screen. And then the z-axis is running in the same way, vertically up and down, again in the plane of the page. And so this way you can almost picture like the xy coordinate plane, it's flat on the surface of the screen, and then we tilt it so that the y-axis goes deeper into the screen, into the page. And so the only difference here is now that kind of space where all three coordinates, x, y, and z, are positive, is now not popping out of the screen or the page from us at us, but instead it's going into the depth of the page. So whichever way makes sense for you to kind of process this is fine. We're not going to be doing, like I said, a lot of sketching or anything like that. The only place where we're going to be drawing anything in 3 dimensions is when we derive the 3D Pythagorean theorem, which we'll get to a little bit later. But being able to visualize 3D space and where points are located relative to the origin still is important. And so if we think about the coordinate plane, again, just drawing that here, we've got the x-axis running left and right, and the y-axis up and down, just like in the plane of the paper or the screen. We know that it's divided into 4 quadrants. So we have quadrant 1, 2, 3, and 4, rotating our way around the coordinate plane. Well, as soon as we introduce a z-axis, now we're going to have 8 regions into which 3D space is going to be divided. And so I think the best way to kind of picture this is imagine the xy coordinate plane that I've drawn here, and now if you were to put your pencil pointing straight up from the origin, that would be your z-axis. And so then you've got kind of these regions that are above the xy coordinate plane, where the z coordinate is going to be positive, and then below the xy coordinate plane, where the z coordinate is going to be negative. And so we have these now 8 regions, 4 of them corresponding to the 4 quadrants that are floating above the xy coordinate plane that you see in front of you, and then 4 of them, so 5, 6, 7, and 8, sorry, the little bit of lag there, that are underneath the xy coordinate plane where the z coordinates are positive. So we need to be able to kind of picture where our coordinates that are given to us here, these ordered triples, are located. So for example, the point 3, comma 2, comma negative 4. So I'm going to go 3 in the x direction, that puts me perhaps over here, 2 in the positive y direction. So if I was just plotting a point in a 2D coordinate plane, I'd be right there. But then we want to go negative 4 units in the z direction. So that means I'd be dropping down in below this xy coordinate plane. So that puts me in octant 5. For the second example, we'll go with green here. So we're negative 6 in the x direction. So that puts me somewhere over here. I'm 1 in the y direction. So let's say we're right about there. And then we're 5 units in the z direction. So I'd be floating up above this xy coordinate plane. So that would put me in octant 2, since we're above the xy plane. We're going to be in 1, 2, 3, or 4. We're going to be in 5, 6, 7, or 8 if we have a negative z coordinate. For the next one, let's shift to blue here. So we've got 4 for an x coordinate. So again, we'll estimate that as being over here. Negative 7 for a y coordinate. So that puts us this way. And then we have 0 for a z coordinate. So we're not moving either up or down off of the xy coordinate plane. So in this case, we're not in an octant, we are on the xy plane. So just like in 2 dimensions, if we have a 0 for an x coordinate or a 0 for a y coordinate, we're on an axis, we're not in one of the quadrants. So too, if we have a 0 for one of our coordinates in 3D space, then that means that we are on a plane that is defined by the other 2 axes. So if 0 is the z coordinate, you're on the xy plane. If 0 is the x coordinate, you're on the yz plane. So you're on the dividing line, the dividing plane, I guess I should say, between octants. But if we jump to the last one, in purple here, so we're 2 in the x direction, so again we'll just kind of estimate that to be there. Negative 6 in the y direction, let's say that's here, so that would be our xy location, and now with a negative 3 z coordinate we're going to be going down underneath the xy plane that we see here, so then that puts us in octant 8. So hopefully we can navigate our way through this as best we can. I think this kind of flat version of the xy coordinate plane with a z-axis poking up out of the page and then into the depth of the screen is probably our best way to visualize which octant a particular point is located in.